Welcome to the RAOB program's Fire Danger and Air Quality Diagram. The following examples are only available with the optional Analytic module. Also note that the demonstrated click and drag sounding modifications were done with the optional Photograph and Interactive module. We have opened the sample sounding with the standard SKU-T diagram view. And in the upper right hand corner is a custom data display of common environmental parameters often relevant to public safety. These parameters, although available to the RAOB basic program, are limited in scope and are summarized from many other factors. These other environmental factors can be seen and analyzed using the Fire Danger and Air Quality diagram. To see this diagram, we'll use the Displays menu, then select the Fire AQ Weather option. Note that you can configure RAOB to automatically open with this diagram by using the Options menu, then select Program Options, and then choose the Fire AQ Weather view, and then close. And the next time you open RAOB, the Fire Danger and Air Quality diagram will be initially displayed. And now we see 6 new nomograms along the left side of the sounding. They provide convenient graphical indicators of common environmental threats to public safety. Before demonstrating each nomogram's capabilities, there is one general limitation to all 6 nomogram indicators, and that is that they are totally dependent on the plotted sounding data with no external input. Most of these environmental indicators were originally developed using additional non-sounding factors such as ground moisture or fire fuel availability. However, these RAOB nomograms are a very good first guess until other data becomes available. Okay, let's first rescale this sounding to better see demonstrated features. To do this, we'll open the Diagram Options panel with a right click, select the Pressure and Temperature tab, and drop the upper millibar limit to 800 millibars into the boundary layer region. Then also move down to the Temperature Scaling options to manually set the temperature range from 0 to 40 degrees, and then apply. And now let's identify the boundary layer region by plotting the mixing height. To do this, we'll open the toolbar with the Analyze menu and then select the Mixing Height option. And just so you know how the mixing height is defined, we'll right-click on the Mixing Height button and look into the Algorithm Options tab. Here at the bottom we can see that the mixing height, or PBL, is the average of 3 methods: the parcel method, the potential temperature method, and the specific humidity method. And more information about these methods is available with its own video. So let's now close this panel and return to the sounding diagram. The best feature of this special diagram is how all the nomograms instantly respond to data changes. For example, let's click and drag the surface temperature into higher values. And as expected, the fire, dust, and heat stress indicators rise, while the fog indicator drops. And now we'll use the Restore menu option to return the sounding to its original data. And now watch the pollution indicator rise when we add a low-level inversion. And this inversion caps the low-level air. And if we also click on the surface wind and use the down arrow key to reduce the wind to a calm value, the pollution potential increases even higher. And if we click on the next wind above the surface wind and also reduce its speed, the pollution potential increases even more. Okay, let's again return to the original profile using the Escape key to exit the wind editor mode, and then the Restore menu option to reset the sounding profile. So, with this Fire Danger and Air Quality diagram, you can see at a glance the overall status of common threat factors. And by adjusting a few data points, you can make a general forecast of future conditions. And with experience in local geography and weather conditions, you can make fairly good short-term predictions with RAOB's interactive capabilities. But the real power of this diagram is what lies behind each of the 6 nomograms. They are user configurable. They are installed with default predictor values, but they can be individually configured for your area of interest. So let's see these configuration options. And as with all of RAOB's diagrams and nomograms, just right-click for more information. And we'll start by right-clicking on the Fire Danger nomogram. and up pops its configuration options panel. And also notice that the panel has 6 tabs, one for each of the 6 nomograms. And if we close this options panel and then right-click on the dust storm nomogram, up pops the configuration panel already preset to the dust storm tab. But for now, we'll select the fire danger tab and examine its options. The fire danger indicator is a composite of 3 separate fire weather parameters, where each can be separately weighted according to local conditions and user preferences. And the current values are also displayed for reference purposes. Also notice that those current values can also be seen at the top of the sounding's custom data display listing. And now back to the configuration panel, notice the generic description of each parameter and the optional info buttons at the end, where when clicked they display related information from RAOB's built-in help files. Okay, now let's move to the Dust tab, where we can see its composite parameters and weighting options. Also note that if you alter the weighting values, you can always return to the default settings with this button. And now on to the Pollution Potential tab, where we can see its 3 composite parameters and weighting factors. And also here, 2 of its parameters are displayed in the sounding's custom data listing. And now the Ozone Concentration tab. This is unique in 2 ways. First, if the sounding data file does not contain ozone data, then the ozone nomogram is not displayed. Second, ozone data itself cannot be interactively altered on this diagram, but its relative weight can be adjusted on this panel. And when you adjust temperature and wind data that define the mixing layer depth, then the associated mean ozone concentrations are consequently affected with the second parameter. The Fog Potential tab contains the most comprehensive set of options of all the nomograms. In this latest edition of RAOB, the fog nomogram is really a split nomogram with indicators for radiation and advection fogs, since depending on weather factors, they can have very different probabilities. We'll close the Options panel and demonstrate the 2 independent fog indicators in action by altering the surface temperature and then the dew point temperature. Okay, we'll now right-click the fog nomogram and return to the configuration panels. The individual fog probabilities are shown here, and they are also listed in the sounding's custom data display. In order to alter the fog configuration settings, we need to click on this Fog Index and Predictor Configuration Tables button. And now we see a dual panel configuration screen, which has its own video. But just to briefly review, it first opens with the radiation options, and you can then click on the advection button for the other configuration settings. And each fog type has both standard predictors and special predictors. These all enable the RAOB user to customize fog analyses to local conditions, both geographic and seasonal. So now we'll close the fog tables and move on to the last tab for the Comfort Index. This is the simplest of all nomograms in that it has no configuration options. It only displays current values. However, predictors can be added as customer requirements are known. The one interesting feature of this Comfort nomogram is that its function changes depending on temperature region. Specifically, it functions as a heat stress indicator in warm temperatures like it does here. And when the temperature drops into colder values, the graphic changes into a wind chill indicator like this. That completes the fire danger and air quality diagram demonstration. Thank you for watching.